So this is the work for Wednesday the 10th of February, your home class. Just apologise, I can't do the writing on the screen live. I'm having trouble with my tablet, but I'm doing my best. So we're going to look at three sections of the book. We're going to look at section 2A, 2B and 2C. I'm not going to get you to do a whole lot of questions. I just want you to do a sample of questions out of each. The areas that you have covered on more than one year and previously. Okay, so the first bit we're going to look at is linear equations. So linear equations, we've got two equations, an equation 5x minus 2 equals 3x plus 2. We subtract the smallest value, the minus 3x. Same on the other side, we rewrite out the equation. Always, we're going to eliminate something and rewrite out the equation. We want to get rid of one of the unknowns first because we only want one unknown there. 2x, so we're left with 2x minus 2 equals 2. Just look at the 2 on this side. 5x minus 3x is 2x. We subtract, we add 2 to this side to eliminate this value, add 2 on this side, we get 2x equals 4, that means x is equal to 2. We solve the equation, and you've seen that a number of years. Then we have a look at a simultaneous equation. So simultaneous equation we've got here, 7x minus 2y equals 8, 4x plus 4y equals 20. Note, let's make sure you do this, number the equations, give them a label so we can refer to them when we're doing the working out. We need to get either these two numbers to match or these two numbers to match. If I multiply this equation by 2, I'll get a 4y there or a negative 4y there to match this 4y. So equation 1 times 2 gives us 14x, double 7x, minus 4y equals 16, double 8. And we're going to call that equation 3. We could call it equation 1 dash. Some people do. I like to give it a new name. Doesn't really matter as long as you're consistent. So now we've got equation 2 plus equation 3, and we're adding them together because we've got a plus 4y and a minus 4y. Signs are opposite, so we add them together. Okay, remember, we are eliminating the 4y. That's the whole purpose of what we're doing. So we go 4x plus 14x is 18x. 4y plus negative 4y is nothing, it's gone. 20 plus 16 is 36. We have got 18x equals 36. That means x is equal to 2. And I'll just pick one of these equations to sub into. I'm going to pick equation 2. So 4 times 2 is 8, because x equals 2, plus 4y equals 20. Minus the 8, so we end up with a 12 over here. 4y equals 12, so then y equals 3. So the solution to our equation is x equals 2, y equals 3, or the coordinate 2, 3. Linear equations. Just get a little bit of practice out of them. If you're really confident, don't spend too much time on them. You're going to work on exercise 2A. That's the suggested questions. It's up to you. You need to do as much work as you need to do until you're confident. If you can do less than that, fine. You need to be really confident with these. If you need to do more, pick some extra questions. Okay? That's there to give you a guide of what to do. So pause the video, go and have a go at those questions, and then come back to the video. You shouldn't spend more than 10 or 15 minutes on those questions, probably not more than 10. Okay, you should be able to do them reasonably quickly. So the second part of today's lesson is literal equations and simultaneous literal equations. They are exactly the same, except they don't have numbers. They just have letters. But you do everything exactly the same. So we've got two equations here. Y equals ax plus c, y equals bx plus d. We just equate. Y is equal to y, so that means ax plus c is equal to bx plus d. Okay, we're going to get the x's on the same side, so I'm going to minus bx over this side. And we've got plus c here, I'm going to get the c over there, so it becomes minus c. So we end up with ax minus the bx. And over here we've got the d minus the c. Factorise it, make x common, so x comes outside the brackets, we're left with a minus b. So when we solve it, we have to divide the a minus b over the other side, and we get x equals d minus c over a minus b. Okay, that's it. To get x, then we have to find y. We can substitute into either of these. I've chosen to substitute in the first one. Your answer might vary. It's the same answer, but it might look different depending on how you go or how far you factorise and expand, things like that. But I'm just putting this in for x, so y equals a times d minus c over a minus b plus c. Just substitute it straight in. And we've solved the literal equation. If we ever find out what a, b, c and d are, we can just substitute into here and substitute into there, and we'll get coordinates for x and y. Okay, a different format of the simultaneous equations. Once again here, I've numbered them 1 and 2. I need to get something same, so I could multiply this equation by a and get an ax. That would work. Or I can multiply this equation by b, which is what I've chosen to do, equation 1 times b. And I get abx minus by equals bc. Just everything's multiplied by b. I've called that equation 3. So now we have a minus by and we have a by. Once again, they're opposite signs, so we're going to add together. If we had have gone with the a's, we'd be subtracting at this stage because they had the same sign. We haven't. We're adding them together. So equation 2 plus equation 3 to eliminate the y's. That's the whole purpose. So we get abx plus the x there, and we get by minus by, which is nothing, and we get d plus bc, or bc plus d. Once again, depending on how you write things out, things might look different, but it's not really different. So now we just take the x out as a common factor, and we're left with ab plus 1. And we're going to divide this bracket over the other side and get x equals bc plus d over ab plus 1. So equation 1, if I put the y over that side and get the y on its own, I have to put the c over that side, so we get y equals ax minus c. I'll just transpose that for formula. So the y is on its own, plus it over that side, which means we have to subtract the c, y equals ax minus c, and then I just substitute in this x value we just found. And we've got our solved our literal equations. Once again, you can get different formats. They can look different depending on direction you choose. They're not. If you put the A, B, C and D in, you'll get the same coordinates. You can check it. You can just pick a name. No, you can't. You need to make sure. You can just pick an A, B, C and D and you should get the same values. So exercise 2B, once again, don't spend a real lot of time on it. There's a guide of what you could be doing. Okay, do a couple, don't just skip over it, at least do a couple, have a go at a couple to make sure you're confident. And pause the video at this point and come back to it when you finish these questions. Okay, the last bit we're going to look at today is just going over and revising linear coordinate geometry. So you'll get all these formulas. If you can't read my writing that well, you can get them out your textbook. Make sure they're copied into your bound reference, just so you've got all this information in the one spot. So this is a distance formula, which effectively it's Pythagoras, this formula. C squared equals a squared plus b squared. And we've got what we're working with. We've got two coordinates, x1, y1 and x2, y2. Okay, x1, y1 is going to be the first point. x2, y2 is going to be to the right of it. Okay, it could be up or it could be down, depending if it's a positive gradient or a negative gradient. But x2, y2 is to the right. So that would mean, well, that'll make our x2. So maybe we should have in this formula x2 minus x1 and y2 minus y1. Doesn't really matter because we're squaring them. So if there's negatives, they disappear. Okay, so the distance formula, to find the midpoint halfway between these two coordinates, we just average the x values, x1 plus y, x2 over 2, average the y values, y1 plus y2 over 2, and we get our new coordinate, which will be halfway in between the other two coordinates. The gradient m is the rise over the run, so y2 minus y1 is the rise. If y2 is less than y1, it will be negative. x2 minus x1, because x2 is to the right of x1, this will always be a positive number, okay? And that will give you the gradient or the slope. If the slope is positive, you'll get a line that goes up. If the slope is negative, if the gradient is negative, you'll get a line that goes down. If the gradient is 0, you'll get a horizontal line. Okay, if you want to find out the equation from the 2 points, first thing you need to do is you need to work out m, the gradient, using this formula, and then you just substitute. You pick one of the points. Oh, there's an error. That shouldn't say, that should just say x minus. So let's, sorry, I'm going to cross that out. That's not there. So our formula, y, which is the y in the formula, minus y1, the coordinate, equals mx, which is the x in the formula, the variable, minus x1, the coordinate. Okay, so we're substituting y1, x1. We could substitute in y2, x2. So that says x1. Just make sure that says x1. And the last thing, any line that has gradient m is going to be parallel. Okay, so the gradient tells us. So if we've got a line that's meant to be parallel, they're not parallel. If they've got the same gradient, they're parallel. For a perpendicular line, the gradient of a perpendicular line, a line at right angles, would be -1 over m, and that would be a perpendicular line. So if one line's got, if we got the line y equals, sorry, not working, y equals 2x, let's just have a go at it. If we've got y equals 2x plus 5, then y equals minus a half. Sorry, x plus c would be perpendicular. Sorry about that, that's why I'm not doing the pen. My tablet has gone nuts. Okay, so that's the third section, and you're going to work on exercise 2C and have a go at those problems on exercise 2C. All the best with that. If you've got any questions with that, come and talk to me about them tomorrow. Try and get through, make sure you do some work out of each of those exercises. I have 2A, 2B and 2C. We need to move through this part of the course quickly because it's stuff that you've covered before. Okay, if you need to put extra work in, put the extra work in. I'll see you in class tomorrow.